Hello guys, this video is a new video in my playlist that is going to be about writing research papers, or the name of the playlist will be the research. What should I name the playlist? I don't know, but I will write it as a research in the playlist. So this is the first video that I'll add in that playlist, which is about how to write a research paper. Okay, in this video I'll be giving examples about chemistry mainly, but you can apply this concept to all of the other fields like biochemistry, microbiology, zoology, engineering, chemical engineering, petroleum, physics, mathematics. Everywhere you can apply this general concept of writing papers to all of your areas of research interest, including engineering, railway engineering, software engineering, computer science, medical science, whatsoever. Okay, I have taken all of these slides from the George Whitesides paper, where he writes about how to write a paper. Okay, let me introduce you who is Whitesides. Whitesides is an excellent researcher and a great scientist of this century. He works at Howard University, America, and he has published almost 1327 articles in his life so far. He is still alive, he is still kicking, and he is still publishing. Man, you have to follow his words because he is the ultimate expert of writing research papers, and he has several highest impact journals. He has published several research articles in highest impact journals so far, and he has massive number of citations, more than, I'm not sure about exact number of citations, but it should be more than how many? What should I say? 50,000, 100,000, 200,000. I'm not sure how big guy he is and how simplified method he has about writing research papers. So this was just introduction about Whitesides, and Whiteside is a guru, or is a chief, or what should I say, is a legend of the writing a research paper. So in this video playlist, I'll be more talking about what kind of research we can do, and this video is more about new PhD candidates, new MPhil scholars, or newly supervisors, or newly appointed faculty members who want to teach their students, or who want to learn themselves or how to write a paper. Okay, this is a process, number one. Number two, it doesn't happen overnight. Number three, you have to keep writing in order to keep improving. And number four, you cannot learn in a day. You need time, you need to be patient, you need to continue, you need to keep going in order to become a better writer, in order to become better at writing research papers, and in order to become a better at publishing research papers. But the one thing that keeps you at a stopping point is, where should I start, or how should I write a research paper? Okay, that is a big question that comes into a mind of every researcher, every new researcher. So this video is going to solve all of your problems related to how to write a research paper. All you have to do is to listen, note down the key points, what I'm going to tell you in this video lecture. Okay, so I'm going to follow the Whitesides, and as you can see, this is the latest paper from his research publication website. That is a 1327 research papers. Man, that's in Agwanti Chemo advanced. Massive publication this guy publishes, and he is the ultimate champion of writing research articles, so we must follow his words. He is an absolute expert in writing research papers. Let's go on and see what first, before, in order to understand what is how to write a research paper, first we understand what is a scientific paper, because if we don't understand what is a scientific paper, then it will be hard for us to write down a paper. Okay, so a paper is an organized description of hypotheses, data, or some say data, and conclusions intended to instruct the reader. Papers are a central part of research. This is very important. If your research does not generate papers, it might just as well not have been done. So many people, so many research groups work around the world, and they do research all day and night throughout the years and years, but they do not publish, or they publish very few papers. That indicates that if your research does not generate papers, it might just as well not have been done. Interesting and unpublished is equivalent to non-existent. So many students have their data and interesting research results in their laptops buried in the folders, but they are unable to publish into the journals. This is the time for you guys to listen my video and polish your talents and publish your results. Come on, you can do it. Just follow my instructions. Realize that your objective in research is to formulate and test hypotheses, to draw conclusions from these tests, and to teach these conclusions to others. Your objective is not to collect data. So many students during their honors, masters or MPhil research time, they collect heaps of data, massive data they contain in their folders, in their laptops, all sort of characterization data, all sort of synthesis, all sort of applications, but they are unable to publish. Man, this is really tough for them to digest this, that even despite of getting great results, they are unable to publish. Okay, if you are a medicinal chemist, if you are an organic chemist, if you are a synthetic chemist, if you are a supramolecular chemist, I am happy to help you in writing research papers and guiding how to write research papers. By the way, I'm a little small man, published 90 plus research papers having citation of 790, and I'm in my PhD third year. I'm not saying I'm the champion, but I know very little things about research that I can share with you guys, okay? You can Google my profile, write FAYAZAALIK, type this name in the Google, you will find my research details and go on from there. Check it out, my research details. Okay, a paper is not, we are discussing what is paper. A paper is not just an archival device for storing a completed research program. It is also a structure for planning your research in progress. If you clearly understand the purpose and form of a paper, it can be immensely useful to you in organizing and conducting your research. A good outline for the paper is also a good plan for the research program. Okay, here is the key point that I'm going to give you. Before you start your research paper, you must make an outline. Okay, you just cannot start your writing research paper without making outline. So first, most important thing for writing a research paper is to make an outline. Okay, a good outline for the paper is also a good plan for the research program. You should write and rewrite these plans, outlines throughout the course of the research. For example, if you have just started research 3 months or 1 month ago or 3 months ago and you want to write a research paper, try to write down outlines. Okay, what are you gonna do it? How you are gonna do it? What kind of results you are expecting from your research? What kind of discussion that you are going to make upon those results, and what kind of conclusion you are going to draw based on your tentative results, and then you can make outlines and plans. And it doesn't, you don't need to wait for all of the results to complete and then write a paper. Okay, you should start making outline from the day one. Okay, that's really important. Said that's missing in so many students, so many researchers, that they do not make outline and they keep doing research work, and a time comes when they got heaps of data and they don't know what to do with that data. Okay, so if you can make outlines and then you can work through that outline, you can publish quickly, you can publish so many papers. Okay, at the beginning you will have mostly plan, because you haven't started your research in the lab, or you just have started your research in the lab just a month ago or a couple of months ago. All you have just planned. At the end, mostly outline. The continuous effort to understand, analyze, summarize, and reformulate hypotheses on paper will be immensely more efficient for you than a process in which you collect data and then you start to organize them when their collection is complete. Okay, most of the people, what they do is they collect the data over a period of 6 months to 1 year, 2 years, 3 years, and after that, completing that collection of that data, then they start planning and then they start making outlines, and after that they start writing papers. What happens, what is the drawback of this strategy is they waste a lot of time by not making outlines and not making plans. And one more thing, before you turn off this video or before you quit watching this video, please don't do it, because you are gonna regret it. I can give you a guarantee, if you listen to me in this video, you are going to learn hell of a lot about writing research paper, because it's not me who is sharing my personal opinion, it's the George Whiteside who is sharing his personal opinion. These are the words of George Whiteside. He has written 1327 papers. Man, you have to listen this. Okay, let's go on. What is the outline? The reason for outlines. Okay, as I mentioned earlier, before you start doing anything, you must start making outlines. Now the question is, why should I make outlines? Okay, I emphasize the central place of an outline in writing papers, preparing seminars, and planning research. Okay, outline is the central part. I especially believe that for you and for me, it is most efficient to write papers from outlines. If you have outlines like introduction, number 1, abstract, introduction, methods, experimental, results, discussion, conclusion, acknowledgement, references, this is the outline. Okay, if you have got this outline, then you can keep filling that outline and so on and so forth. An outline, what is an outline? An outline is a written plan of the organization of a paper. That what is your plan to write that paper? Okay, forget about the results that you are going to get from the research that you will do in the lab. Forget about it for a minute. Try to think on a paper that you are going to visualize it. Imagine, visualize it. You are going to enter in your lab and doing some activity in the lab, growing cell culture or doing microscopy or organic synthesis or catalysis, whatever you name it. So think for a moment that you are going to do some sort of experiment, and that experiment is going to give you some kind of a results, and that results will be either A, B, C, and I'll explain if I get the result A like this, I'll explain if I get the result B like this, and if I explain the result C like this. Okay, so you visualize your these situations in your mind and then write it down in the form of outlines, and then you can do your research and then come back to your outline and check it out what sort of situation you have from your outline. Okay, and then you just write it up. Easy. An outline is a written plan of the organization of a paper, including the data on which it rests. You should in fact think of an outline as a carefully organized and presented set of data with attendant objectives, hypotheses, and conclusions, rather than an outline of text. An outline itself contains little text. If you and I can agree on the details of the outline. Okay, what is I in this sentence? I is George Whiteside. He is talking to his students. Who is George Whiteside? George Whiteside is an excellent researcher who has published 1327 research articles in highest impact journals. So if you and I can agree on the details of the outline, that is on the data and organization, the supporting text can be assembled fairly easily. If we do not agree on the outline, any text is useless. Much of the time is writing a paper goes into the text. Most of the thought goes into the organization of the data and into the analysis. It can be relatively efficient in time to go through several, even many cycles of an outline before beginning to write text. Writing many versions of the full text of a paper is slow. All writing that I do, papers, reports, proposals, and of course slides for seminars, I do from outlines. I urge you to learn how to use them as well. By following the guidelines of George Whitesides, I have published 3 book chapters and 90 plus research papers. If you're gonna follow this method, you will publish hell of a papers, trust me. And you are more than welcome to ask me any questions in the comments related to publishing research papers, particularly in the area of medicinal chemistry, organic synthesis, supramolecular chemistry. Okay. Now the big question is, how should you construct an outline? What we have discussed in this video is what is research paper, what is outline, and now how should you construct an outline. Okay, the classical approach is to start with a blank piece of paper. Okay, this is how you start writing research paper. You take a paper which does not contain anything. It's blank. It's absolutely blank. And write down in any order, doesn't matter, all important ideas that occur to you concerning the paper. Ask yourself the obvious questions. Why did I do this work? That's the most important question you should ask from yourself. Why did I do this work? You did this work because this was never done before. You did this work because you think it's a problem-solving approach. You did this work because you wanted to obtain a new knowledge. You did this work because you wanted to find out a new application. You did this work because you wanted to create a new catalyst. Why did I do this work? Why did you do this work? Okay, what does it mean? Is it belonging to a novel area of research? Is it belonging to what sort of area of research? What hypothesis did I mean to test? What ones did I actually test? What are the results? Did the work yield a new method of compound? What measurements did I make? What compounds? How were they characterized? Sketch possible equations, figures and schemes. Okay, sketch. That means you do not have any results. All you have a blank paper, piece of a paper. You are asking yourself these questions and try to write down the answers of these questions and sketch it. Okay, you don't need to go inside the lab and do all of the research and then come back from the lab with the results and then plan outline and then start writing research paper. Man, this is crazy. You first write an outline and then go and do your research. Okay, if you start the research to test one hypothesis and decide when you see what you have that the data really seem to test some other hypothesis better, don't worry. Write them both down and pick the best combinations of hypothesis, objectives and data. Often the objectives of a paper when it is finished are different from those used to justify starting the work. So many times you have seen that you start a research from some area and you end up with another point. That's the beauty of research. Don't worry about it. You just try to make outlines and follow the results that you get it. Okay. Much of good science is opportunistic and revisionist. You keep revising your hypothesis, you keep revising your methods, you keep checking your approach. Okay, when you have written down what you can start with another piece of paper and try to organize the jumble of the first one. Sort all of your ideas into three major heaps, 1 to 3. Number 1, introduction. What is introduction? What you should write in that introduction is, why did I do the work? What were the central motivations and hypotheses? Number 2, results and discussion. What were the results? How were compounds made and characterized? What was measured? Number 3, conclusions. What does it all mean? What hypotheses were proved or disproved? What did I learn? Why does it make a difference? That should be in the conclusion, and conclusion is the hardest part to write. I really struggle in writing conclusions. Okay, it's not easy. Next, take each of these sections and organize it on yet finer scale. Concentrate on organizing the data. Construct figures, tables and schemes to present the data as clearly and compactly as possible. This process can be slow, don't worry about it. I may sketch a figure 5 to 10 times in different ways, trying to decide how it is most clear and looks best aesthetically. Beautiful pictures create beautiful images, create beautiful tables. Try to come up with creative ideas, making different side of how you can present your data. Okay. Finally, put everything, outline of sections, tables, sketches of figures, equations in good order. When you are satisfied with what you have included all the data, or that you know what additional data you intend to collect and have a plausible organization, give the outline to me. I mean, not to me. George Whiteside is talking to his students, okay? Simply indicate where missing data will go, how you think hypotheses will look, and how you will interpret them if your hypothesis is correct. I will take this outline, add my opinion, suggest changes, and return it to you. It usually takes 4 to 5 iterations, means keep going, coming back, often with additional experiments to agree on an outline. When we have agreed, the data are usually in or close to final form, that is the tables, figures, etc. in the outline will be the tables, figures, dash in the paper. You can then start writing with some assurance that much of your purpose will be used. The key to efficient use of your and my time is that we start exchanging outlines and proposals as early in a project as possible. Do not under any circumstances wait until the collection of data is complete before starting to write an outline. That is a big mistake everyone makes, most of the people make. They wait until they get all of the results, all of the data, and after that they plan out, and after they make outlines for their research for the paper. Okay, do not wait. The data will never be complete. All you have to do is to pick most important data. No project is ever complete, and it saves enormous effort and much time to propose a plausible paper and outline as soon as you see the basic structure of a project. Even if we decide to do significant additional work before seriously organizing a paper, the effort of writing an outline will have helped to guide the research. What is an outline? What an outline should contain? It should contain title, it should contain authors, it should contain abstract. Do not write an abstract. That can be done when the paper is complete. Abstract should be written at the last. The last thing that you should write in the paper is abstract, and that comes right in the beginning. Even though when you look at the research papers, you see a title, you see a list of authors, and you see a list of then you read abstract. But when you write a paper, abstract should be written at the end. Introduction. How you should write introduction. The first paragraph or two should be written out completely. Pay particular attention to the opening sentence in the introduction. Ideally, it should state concisely the objective of the work and indicate why this objective is important. In general, the introduction should have these elements: the objectives of the work, the justification for these objectives, why is the work important, background, who else has done what, how, what have we done previously, guidance to the reader, what should the reader watch for in the paper, what are the interesting high points, what strategy did we use. Summary and conclusion of the introduction. What should the reader expect as conclusion? In advanced versions of the outline, you should also include all the sections that will go in the experimental section at the level of paragraph, subheadings, and indicate what information will go in the microfilm section. Results and discussion. The results and discussion are usually combined. This section should be organized according to major topics. The separate parts should have subheadings in boldface to make this organization clear and to help the reader scan through the final text to find the parts of interest. The following list includes examples of phrases that might plausibly serve as section headings. Okay, this is related to chemistry, but you can apply these headings of results and discussion to your research, your engineering research, your computer science research, your mathematics, physics, biology, microbiology, chemistry. You can apply these headings to your area of research. These are the chemistry headings: synthesis of alkane thiols, characterization of monolayers, absolute configuration of the vicinal dial unit. Hysteresis correlates with roughness of the surface, dependence of the rate constant on temperature. The rate of self-extend decreases with the polarity of solvent. Try to make these section headings as specific and information rich as possible. For example, the phrase "the rate of self-extend decreases with polarity of the solvent" is obviously longer than measurement of rates, but much more useful to the reader. In general, try to cover the major common points: synthesis of starting materials, characterization of products, methods of characterization, methods of measurement, results, rate constants, contact angles, whatever. In the outline, do not write any significant amount of text, but get all the data in their proper place. Any text should simply indicate what will go in that section. Section headings, figures with captions, schemes with captions and footnotes, equations, tables correctly formatted. Remember to think of a paper as a collection of experimental results summarized as clearly and economically as possible in figures, tables, equations, and schemes. The text in the paper serves just to explain the data and is secondary. The more information can be compressed into tables, equations, etc., the shorter and more readable the paper will be. Last outline is conclusions. In the outline, summarize the conclusions of the paper as a list of short phrases or sentences. Do not repeat what is in the results section unless special emphasis is needed. The conclusion section should be just that and not a summary. It should add a new, higher level of analysis and should indicate explicitly the significance of the work. Number 7 outline is experimental. What you should write in the experimental is include in the correct order to correspond to the order in the results section all of the paragraph subheadings of the experimental section. In summary, start writing possible outlines for papers early in a project. Do not wait until the end. The end may never come. Organize the outline and the paper around easily assimilated data, tables, equations, figures, schemes rather than around text. Organized in order of importance, not in chronological order. An important detail in writing papers concerns the weight to be given to topics. Neophytes often organize a paper in terms of chronology, that is, they give a recitation of their experimental program starting with their cherished initial failures and leading up to climatic successful finale. This approach is completely wrong. Start with the most important and put the secondary results later if at all. The reader usually does not care how you arrived at your big results, only what they are. Shorter papers are easier to read than longer ones. Some points of style that you should follow: do not use nouns as adjectives, not ATP formation reaction product, but formation of ATP product of the reaction. Okay, that's the correct version. Formation of ATP is correct, not the ATP formation. Reaction product is incorrect because the correct version is product of the reaction. The word "this" must always be followed by a noun so that its reference is explicit, not "this is a first reaction, this leads us to conclude." Instead, you should write "this reaction is first, this observation leads us to conclude." Describe experimental results uniformly in the past tense, not adding water, not addition of water gives product, but addition of water gave product. Use the active voice whenever possible, not "it was observed that the solution turned red," but "the solution turned red." Use active voice. "We observed that the solution turned red." Complete all comparisons, not "the yield was higher using bromine," but "the yield was higher using bromine than chlorine." Type all papers double spaced, not single, 1.5 spaced, and leave 2 spaces after colons and after periods at the end of sentences. Leave generous margins. Assume that we will write all papers using the style of the American Chemical Society. You can get a good idea of this style from 3 resources. The journals. Simply look at articles in the journals and copy the organization you see there. Previous papers from the group. By looking at previous papers, you can see exactly how a paper should look. If what you wrote looks different, it probably is not what we want. The SCS Handbook for Authors. Useful detail, especially the section on references, page 173-229. I also suggest you read Strunk and White, The Elements of Style. A number of other books on scientific writing are in the group library. These books all contain useful advice but are not lively reading. There are also several excellent books on the design of graphs and figures. Thanks for watching this video. I hope I have conveyed my message. In one line, the message is to write outline and what should be the outline and how you should construct the outline and what you should write in the outlines, and then you can put text, figures, captions, schemes inside those outlines and write sentences around the figures, around the tables. I hope you learned how to write a paper. If not, then please let me know in the comment section. What are your queries that is still there in your mind? I can help you with that. Thanks for watching. Take care. Bye.